Okay, thank you. So, welcome. My name is Tom Schindl. I'm author of the FX Clipse framework, which is an Eclipse project allowing you to do JavaFX applications and UIs. So, there are three phases or three things that FX Clipse does. The first thing is we provide an IDE plugin that allows you to have an editor that understands FXML, that allows you to understand the CSS properties, for example, in CSS. This is nothing coming by default from Eclipse. Well, Eclipse knows about web CSS, but it doesn't know about JavaFX CSS. The second phase, and this is what Andres got wrong in his presentation, we are not just a platform. We also provide libraries that run on the ordinary class path or module path. So we have libraries, and on top of that, we build a platform. We're using Eclipse technologies to really giving you a complete application framework and application platform. In the IDE space, as I said, we have XML editors, CSS editors, we have project wizards, we have direct preview of FXML and CSS in our IDE, but I won't show that today. I'm talking more about library section, library part of FX Clipse. So in the library section, there we have binding extensions. When you use property bindings, there are missing parts in JavaFX. We add them. We integrate ourselves into EMF, Eclipse Modeling Framework, allowing you to bind EMF models directly to JavaFX UIs. We have specialized controls. So we have extra controls for example, rendering or showing file system information and all the stuff around that. We have specialized layout containers. If you're coming from SWT, there are layouts like the grid layout that are coming from SWT. We just ported them to JavaFX to feel that you feel at home at JavaFX if you're coming from the SWT background. And at the application framework layer, when we talk about Eclipse, we talk about OSGi. So we somehow need to integrate JavaFX into the OSGi world. And we also did, because I was one of the main authors, or one initial authors of Eclipse 4, we integrate ourselves in Eclipse 4 and provide a complete application framework built on Eclipse technologies, built on top of OSGi, giving you all the power you have from the Eclipse platform, but we substitute SWT against JavaFX. Let's take a look at the library area of FX Clipse. So we have the core library. The core library has nothing to do with UI. It's similar to in JavaFX, you have JavaFX Base, which is the property system, for example. So herein we have things. The second part of the library is the UI libraries. As I said, there we have specialized controls and all the stuff in there. So what do we have in the core library? We have an advanced service system. Somebody of you probably knows service loader in plain Java, or if you're coming from OSGi, there's the declarative services framework you can make use. We have an abstraction of that in FX Clipse. I will show in a minute. We have an event bus, allowing you to do a publish and subscribe event notification in your system. This is a core library. This runs in OSGi and outside of OSGi. It's just a library like Guava you add to your system. So it's something that anybody can use. We have a logger abstraction. I will show that. Internally, we just use our internal logger. We don't depend on any external logging framework. Well, Garrett, I think, said it today. So if you write a control, you don't want to have a logging in there and say you have to have log4j, because I'm logging with log4j, so you need to have some facade. Most people tend to use SLF4j, but we said we create our own internal abstraction, use that. We publish it in the public, so you can make use of it, but you can also use your own logging framework, which is part of your application. This is something that we don't make you depend on any framework at all. We have an annotated string, which is a specialized string allowing you to annotate sections of it, allowing you in the UI then to have colorized labels and all the stuff around that. We have listener utilities, we have Eclipse data binding framework integration, Eclipse modeling framework integration. This is all headless. This is all plain Java. This is working inside OSGi, outside OSGi. Library is the library is the same. We have layout containers. We have file system viewers, directory viewer, file viewer. We have multicolored text support, something like rich text FX, with editing support. I will show a big demo on that. We have a preference system for preference UI, which is ported from SWT, from the JFX library of SWT. We have a docking support, we have tab pane with real drag and drop and detaching. We have a lightweight dialog API. We have an icon font node. We have list and tree utilities. So a lot of stuff in our library section that can be used in any application. Let's take a look at the core libraries and what's in there. First, you have this advanced service system. We need a service system that works inside and outside of OSGi, because we make use of the services already in our basic controls, and we want that service system to run in OSGi and outside of OSGi. The problem is that the service loader service system of plain Java is very limited. If you're coming from an OSGi background, you say service loader is something for kids. I want a real service registry with a real service API. Solution, we took the decorative service implementation from OSGi and made it run on plain Java. So you get all the powerful stuff you get from decorative services of OSGi in a plain Java environment. So let's say we have two services, the hello service and the translation service, and we do the implementation. So we do the implementation so that the hello service needs to access the translation service to translate some string from English to German, for example. When you're coming from OSGi background, what you're doing, the only thing you now need to do to get the service into the service registry and available at runtime is you add some annotations. You add a component annotation and you add a reference implementation. You say here, this service can only live if there is a translation service available, so because it's mandatory. The decorative service system of OSGi has something like dependency injection. With service loader, you can't do inversion of control. It's not possible with the service loader pattern, because service loader pattern always goes out and searches for services. You cannot make, for example, connections between services. This is allowed by our service registry. And what does that mean at runtime? When we want to discover the service, all we need to do is call service utils get service. We return an optional because it might be that the service is not there. And if present, then we call the service API. In the end, this is the call you need to do to get the full-blown OSGi decorative service system in plain Java. This is a plain Java class. It's a main in the end. So this is the first cool thing I think we have. Then we have an event bus. What do you want to have? We want an event bus with publish and subscribe API, which is something Eclipse 4 has. It needs to work inside and outside of OSGi, once more. And it needs to provide type safety. The version that you get from Eclipse 4 has the problem that it's not type safe. And I'm in Java. I'm not programming JavaScript. I have no types. I want to make use of the type system, even in my event bus system. So what we have is the first thing you need to define is a topic. And this topic is typed. So over this topic, I can only send a string. I cannot send a number. I cannot send a date. It's typed to string. So when I have my sample and want to publish information on this event bus, I call publish, then the topic, and then the value I want to publish, which has to be a string. Otherwise, the compiler will step in and say, hey, you're passing a double or a number here. That is not allowed. The last parameter here is important. This says we're doing this in a synchronous fashion. So we just return from this call if all subscribers to this topic have done their work. And when we want to subscribe to a topic, we subscribe it, we get an event object, and from there a data object gives us the information. This is a lot of boilerplate code for the subscription, because most of the time we are not interested in the topic, we are just interested in the data information. So we have a shortcut for that. We replace that and say event bus data, and there you give it a method reference. That's it. Let's look at thread synchronization. If you do server calls, you most of the time want to do them in a background thread. And when the server comes back, the completable future, or whatever strategy you're using, you need to synchronize yourself back on the JavaFX thread. First thing, but we normally do that with platform run later. The problem with platform run later is when you, for example, apply MVVM, your view model should not depend on the UI technology. So you are in trouble, because when you come from the server to the VM model, you need to call platform run later. How do you do that? you need for your unit test to boot up the JavaFX system, that platform run later is really working. So all this trouble and your view model suddenly has a dependency on JavaFX. It cannot run anymore in Swing. It cannot run anymore in SWT. You are stuck there to have JavaFX available. So that's why we created an abstraction for that. And we needed more features. For backwards compatibility, we need to halt the program flow, but still process events, mouse events. This is, in SRG, you call it spinning the event loop. So you halt the program flow, but still you get information about mouse events and all the stuff around that. We needed that API. We wanted to have delayed executions. I will show what I mean with that in a minute. And we need to have not a platform run later, we need a synchronized call. So that blocks until the run label is really finished. Something that is very error prone. So that's why JavaFX doesn't provide a run and wait later, because you can easily produce deadlocks. But once more, we have to support in Eclipse some backwards API that have been created with synchronous execution in mind. So we provide an implementation for you there. And there is much, much more in this interface. Let's take a look at it. Schedule execution. So when you have the task to schedule a task in 1 minute, the first reaction of all Java developers is, oh, I start a timer and a timer task, and then I do the 1 minute, and then I call platform run later to come back from the background thread, from the timer task to my JavaFX system. This is not a good idea. You're creating threads, although they are not needed. In JavaFX, you would do that with a timeline. Something like an animation. You have this constant animation pulse running in the background. So our implementation in the background is not using any threads. It uses the timeline to delay the execution of the run label. So we don't have to synchronize back and forth between the JavaFX threads, and we don't need any new thread in the background doing the timer task. Delayed bindings are very important in business UIs. This sample here, whenever I type in a text field, I get the callback in my listener. It's a change listener. Every single character I'm typing. If I have to do complex computation, it might be that I want to, well, while the user is typing, I let him type, and once he's stopping for a certain amount of time, I want to process the input. This is what we call delayed execution. And this is what ThreadSynchronize provides us. All we need to do, we have thread synchronized, we give it the timeout, we give it the property it should observe, and we give it the callback, the consumer in this case, that should be called if nothing is happening inside 200 milliseconds, for example. Thread synchronization, once more. Let's take a look at this code once more. It's the event bus system. The first version sent here true. When we now switch that to an asynchronous version, we are getting in trouble because this method is called on a background thread because we are sending this topic asynchronously. So non-blocking method call up here. So this method, setText, would be called on a non-UI thread. What we provide in ThreadSynchronize is a method that says, give me the consumer, I will wrap it for you, and I guarantee that this method setText is always called on the UI thread. And when we pass that along to our final event bus subscription, then we are achieved thread safety. Listener utilities. Once more, problem domain. Let's take a look at those lines of code. First line, I'm 99% of the time not interested by if a change listener on the observable and on the old value. I'm most of the time interested of the new value. Why do I have to provide 3 of them? Even when I use the method reference, I get unused parameter warnings. Doesn't make sense, right? The second line produces a compiler error. This is, I think, a design flaw in the JavaFX APIs that for lists you have, and the compiler doesn't know whether you want to attach here an invalidation listener or a change listener. We are solving that with a specialized class called FX Observable Util, which has an onChange method where you can pass the lambda and it just gives you 1 value. the new value. And this is the guy I'm 99% of the time interested in. And for observable list, we have a method onChange and onInvalidate that describes in the API what listener type you're adding. We always have in our APIs just the onChange method because this guy returns a registration object allowing you to dispose the subscription. So you're not relying on add and remove methods, which are error-prone when you use method references, for example. We rely on the fact that we return here an object that allows you to dispose the subscription later on. Yes? When you want to, well, let me do that later on. I will show you how we do that in our APIs. Binding extensions. Let's suppose we have this JavaFX beans. We have an address. We have an address with a street property and with a person. We have a relation here. So we have address can change. So we have a property here. So how can we do that? This is most of the time it's called a detail binding in form technologies. This is nothing you can do with plain JavaFX APIs. Let's say our UI looks like this. We have a house number, text field where I can enter the house number. How can I bind that to my domain, to my view model or domain model that I just showed you? Well, we get in here a person, master person, it's an observable property. And what the first thing we create is a so-called bind stream. A bind stream takes an observable value and then allows you to call map functions on that. We map from the observable master to the address property. Fully type safe, not like the bindings select API where you pass strings. This is typed. This gives you type errors when you try to pass something that's not working. And then we collect the final result. And the last argument is the street property we're really interested in. And so we have this property always contains the current selected person's house number. And it's a property that's very important because only a property can be bound bidirectional to a field. But then we have the next problem in JavaFX. We have an integer property and want to bind that bidirectional to a text property. This is not there by default in the APIs. What we have a bind bidirectional. We give it our house number property, it's a text property, it's the target. Then we provided the domain property, and then we provided the conversion going from text to integer and going from integer to text. Good. Beside that, we return a binding object because there can be errors. When you enter in a text field something that cannot be transferred to a number, converted to a number, I need to get this information. Probably I want to highlight that and mark the text field red. That's why we return a binding status, and the binding status can be observed. And if the binding status goes from OK to error, we add just, for example, a pseudo state change in the end. This is all API we're providing because we do form-based UIs most of our time. Annotated string is a car sequence. When I show you later on our demos, all we have in our APIs, we never expose string property. We always expose object property of car sequence. Because then we can not just put a string in there, we can do a string buffer, we can do a string builder, we can do any car sequence, and we have a specialized car sequence allowing you to annotate parts of a string. It's an immutatable class, so we need a builder to build it, we need to annotate a string, and here we are building, for example, when I have a code editor and I want to highlight all the sections in my string, I can annotate those elements. You see, this is a very general API. The string is the type that we pass as a modifier. So we could also do an enum version of that guy just by say, OK, instead of annotating with a string value, I'm annotating with an enum. In the background, this is nothing or similar to a string buffer with a car array, jar array, and there we just remember what parts of the string are annotated with which value. We use that in our APIs then all the time. Logging. First of all, as I said, we didn't want to depend on any external framework. That's why we have our own abstraction. By default, we ship a Java util lock implementation, but you can have from us log4j, SLF4j implementations. All those are available, or you write your own one. It's just an interface to implement with 3 methods, I think, and you are done. We have 2 APIs available. We have a traditional log4j-like API, and we have a Fluent API inspired by Google Fluent Logger. Just to show you how that looks like in real code. Our traditional API can be called like this, like you're used to it. You have debug F, you have arrow F, you have info F. And this is the default API. We emphasize or would like in future to use this API. A Fluent Logger API. You have a logger, you can create a Fluent Logger for it, and there you set debug and error. You create a so-called Fluent log context. The advantage is that at this point we already check whether the log level is debugged. We don't have to do it in any call. If you find out at that very moment that you created this log context and the log level is not debugged, this guy is a no-op. It never ever has to check back whether the log level is set to debug or not. Same on something that I find very strange in these APIs with arrowF. You always have to pass the throwable in the arrow case as the first parameter to get the stack trace locked. And if you forget that, you're in trouble. You just get the error message. The Fluent Log API says, oh, we have a Fluent log context. We log with an exception, and then we just have the log methods with parameters at the end. So the API is much more consistent. Another problem we have here, well, we're iterating here 1 million times. So we're creating 1 million debug outputs. Maybe this is just for me, by debugging, to know, oh, the loop is still running. So probably I want to log just every 1,000 entry that's going there. With the Fluent Log API, you have this throttle count by 1,000. This means only every 1,000 entry is logged. All others are skipped until then. So this is API. Google has the same API. The Fluent Logger API from Google is completely the same. We have taken it as an inspiration for us. Okay, I'm skipping the UI libraries because we will see them in the demos. Let's talk a little bit about frameworks. First, we had to integrate JavaFX into OSGi, which is, not so simple. Problem 1, JavaFX is on the extension class path. It's not on the boot class path on Java 8. This is a real problem to OSGi or Equinox in special, because Equinox by default delegates class loading to the boot class loader. So it strips out the extension class loader. Well, the problem is very easily solved by running Equinox or OSGi with a specialized parameter, -org OSGi framework bundle parent is ext. This means OSGi will use the normal Java delegation for class lookup. The second problem is more involved. SWTFX, the integration of JavaFX into SWT, depends on SWT. So it cannot be on the extension class path. So we somehow had to manage to get SWTFX loaded at runtime in OSGi, giving it the correct parent class loader that it can find the SWT classes. This is solved using a so-called adapter hook. So everything was good, everything was fine, and then Java 11 came along. JavaFX is not shipped with Java anymore, so it's not available. You ship it as an ordinary library. But this ordinary library is designed to run on the module path and not on the class path. It might work on the class path, but it's not designed and not supported by the JavaFX community. This is a problem because now we are in OSGi. We have JavaFX that needs to run on the module path, but we are having OSGi running in the unnamed module. What are we doing? We once more use our adapter hook strategy. When we look at the level, so we have the JavaFX root layer, which contains Java base and all this stuff. Then we have OSGi running in the unnamed module. It's just an ordinary Java library running on the unnamed module because it runs on the class path. And what we do now at runtime, we do something, many people think that the GPMS or Java module system is static. This is not true. You can spin at runtime so-called layers. and install their modules at runtime. So what we are doing is, at the moment we detect somebody is cloning a JavaFX class, we spin up a layer. There's a GPMS layer, Java Module System layer, where we install the JavaFX binaries. You can ship them with your application. We install that in this layer and delegate the class loading, not to this layer, but to that layer. This is something we are solving for you, and it works exceptionally well. If you're interested what GPMS or Java Module System code is behind this dynamic stuff, there is a GIST where I demonstrated that. We have now specialized support. Well, what you can do, well, we can help you when you don't ship the JavaFX libraries, but you know the path on the file system where the SDK is installed. For example, at development time, you can give us a direct class path to the libraries, to the JavaFX modules. Or we have a specialized way to ship JavaFX binaries packaged in an OSGi bundle, which we extract at runtime and install and layer this GPMS layer at runtime for you. So that you don't have to do that yourself. There is a P2 update site that allows you to integrate that in PDE projects, and a Maven update site allowing you to do that in Maven. Advanced features we need to support. When you run with the module path, there are specialized command options allowing you to add export opens, to open a module, for example. Controls of X needs that because it depends on internals of JavaFX, and it cannot run with a -- module add exports clause. Because we are now doing this all at runtime, spinning up the layer. We have specialized manifest headers allowing you to say, I'm an OSGi module and I need to access an internal class of JavaFX base, for example. You just need to add an add options, opens. You add an add exports, you add an add reads. This is how we use it. For example, our UI Workbench FX bundle needs access to ComSun JavaFX application. This is an internal class we need to access to bootstrap an OSGi application, and if Eclipse application and JavaFX application on OSGi. And this is how our bundle now looks like. So it allows us to dynamically add exports and all this stuff. Okay, now let's talk a bit about Eclipse 4 on JavaFX. Well, Eclipse 4 is built around a concept called application model. It's the central of your application. All information is going in there. What windows are open, what menus are there, how big is the window, what is the active part in my system. All this is tracked in the so-called central application model. It provides you a dependency injection container, providing you access to services and state in your application. And in terminology of Eclipse 4, everything is a service. Rendering is a service, selection propagation is a service, model persistent is a service, everything is a service. And what Eclipse 4 was designed to is it ships default implementations, and if you're not happy with the default, replace it with your own service. And this is what we did with Eclipse 4 on JavaFX. We just remove the rendering that's based on S3T and delegate that to JavaFX. So, let's talk, before we come to the demos, let's talk a little bit about the future of E4 on JavaFX. We have better support to not only implement a few applications on Eclipse, but also on VS Code, NetBeans, and IntelliJ. This is possible because we now ship everything and build everything based on Maven. We don't need the manifest first approach anymore that's part of Eclipse. And the future, and this is a long-term plan, is that we make the OSGi runtime layer optional. So you can say, I want to run on OSGi, I want to run on GPMS, or I want to run without any module system. So now to the demos. What can we build with all this stuff? Let me just switch here. For example, what we've been implementing is a BDF viewer on top of all this stuff. If it opens, here we go. We can open a BDF file. Let's open OSGi PDF. This is a very big one, This is a PDF viewer written in pure JavaFX. So it allows me to scroll through the pages. It allows me to zoom in, zoom out. Here, right? We can select text in here, double click here, we can annotate it. All this is possible and built on top of JavaFX. And if the detail in the background, all what we see here is a path, SVG path. We are not using the default implementation from JavaFX, because with the default implementation, each page would take about 18 megabytes just for the path rendering. We replace that through our own path implementation that just backs itself with a float, which is the background stuff in JavaFX as well. Even in the front end, you see a double, and not just a double, but you see a double object. And that is where the memory is taken. So we have our own SVG path implementation reaching to internals of JavaFX, of course. Otherwise, it's not possible to implement that. We have a read mode, where we can jump through pages, and we support all the stuff that is in part of the PDF specification. We did that project together with a customer. Christopher is sitting in the audience. So this is a commercial thing. It's nothing that is open source. So normally I only talk about open source, but it's a real cool demo, because there a lot of the binding APIs that I showed you are going on in the background here. Okay, good. Another cool application you can build on top of that is, I switch to my other Eclipse workspace. And I've been working on and off on something I called Argo. It's a small IDE. Let me put it this way. So Argo it's not yet very sophisticated. I have here demo. Well, what you can see here is the first time I clicked on the wrong? Yeah, so double click and open. First time I need to initialize all the Java system. But this is a code editor using syntax highlighting based on pure JavaFX. This guy has things like autocompletion. So I call the getName method to see the Java doc in the background popping up, just like you used to from an IDE. And this is real, this code is real. So this is get compiled in the background. So when I say here Zurich, save it, and run it, it will open up and run my Java application. I've just programmed in my IDE. Background is, this is running Eclipse in the background. This is, well, naturally you get all the features from JavaFX. Switching to a dark theme, switching to a light theme. This editor is very powerful. So the syntax highlighting, you can have Java classes with 100,000 lines of code. This is all virtualized in the background. So we are just using the nodes we really need to see on screen. This is something you can build with Eclipse 4 plus JavaFX as an application framework. Okay, let's get to something, to a real business UI we're developing. I need to hurry up a little bit. So we have, together with the Department of German Justice, we are developing, that's the wrong application, sorry. This is not looking that nice. So simple application. This is a demo application we are developing for a big project together with the Department of German Justice. This is a business UI. This is how business UIs look like. So I can open here. This is something like a mail application. Let me put it this way. It's designed for a bigger screen size, as you see. So this is, on the left-hand side, we have specialized list. You see, it's iPhone-like. It keeps the header at the top. You see that the scroll bars are fading out and fading in whenever you interact with this control. It's fully virtualized. So here, the background thing is a long. This means that you can have milliards or billions of items in there. It's not a problem. Well, it's a problem to your memory if you load them in memory, but for the list itself, it's not. We have a special, well, generally speaking, this is all built on our own scroll pane. You see it on the right-hand side as well. So we use the same scroll infrastructure to build a virtualized list and to build a list on the right-hand side. You also see on the right-hand side our table control, which is custom written. It's not a default table control. It has specialized features. First of all, it's very lightweight, so we never ever show vertical scroll bars here in the table. You have only one scroll bar on one region in your system, not multiple of them. If you have a table here with hundreds of entries, we use paging, going back and forth. I can show you this in our small little demo in our showcase application. Oh, it's not the showcase application, sorry, it's the table view sample, because we see all the features of the table. So we see we have editing support, which really works, which is not normal to a JavaFX table view. Well, it really works, it really escapes. I can navigate in there. With scrolling, you see we have fixed columns. You should see the shadow that you have here for the fixed column. We can put that fixed column on any column in here. So from the left to right, so that we fix stuff. This is all working internally. The thing is, this is a work of a man week, I'd say, implementing this control. How long did you ever try to debug and find problems and get table view of JavaFX working? I guess it's more than a week, right? So we can here. And you see here we have paging. So when we go through the pages, and we naturally flip pages when we navigate in here. So this is our table control we've written. Okay, good. Now let's get to the really, really cool stuff. I'm happy to introduce today to you a framework called Drift. What is Drift? Drift is direct rendering. Yeah, and now I managed to get my screen out. Rendering infrastructure. What this will allow you to do in future is, well, first of all, it's a research project for multiple companies with Best Solution leading it. It allows you to directly embed OpenGL content in your JavaFX application. Don't fuss around with the scene graph anymore if you have really big, complex rendering infrastructures. This is something that we implemented together with 3 partner companies. Netherlight, a company in the automotive space and aviation industry. Eclipse, a consulting company located in Munich. And Best Solution leading the complete effort. What can you do with that? Just the background. This is a JavaFX application. It doesn't look that nice, but the cool thing is we are now loading a 3D model, which is around 1.5 gigabyte in memory. We can navigate in this model. You see, this is the JavaFX front side. This is our 3D model. We can zoom in, we can zoom out, we can rotate. This is a native rendering technology that was developed for 10 years. But we can now embed it into JavaFX to create a business UI on top of that. Right? So we can manipulate the complete scene graph. You see, it's in the background. JavaFX is overlaying it. It's just a node in the scene graph that we're seeing here. It's just coming from an external system. Let's see what he's now adding stuff to the scene graph dynamically. Well, when he zooms out, you will see how big the model really is. It's amazing. This is a fab with every robot in this factory. That's an automotive factory that we are seeing here. This is an application built by Netherlight. So you now see, well, we added the whole fab, and now we zoom out and see how big this fab is, right? But there's every single robot in this factory is in this model. Drift. Drift works like this. We have the GVM, we have JavaFX. We have the Drift API. We have the Drift native API. And we have our existing rendering OpenGL code base. What we do at runtime, or technically, don't ask me about the details. I'm not that deep. I'm the manager of this project. I'm not the programmer or the guy who implements that. So we have JFX and we have our native renderer. And what we do, we create a texture in JavaFX and expose that to our DriftFX APIs or framework. And then we present another OpenGL texture to the outside world. And when you draw on this texture, we split it through to JavaFX. And it's part of the scene graph. We support in-process support. We have on Windows, we support 3D as external rendering technology. OpenGL, we cannot support Metal there. We probably could support Vulkan. We haven't looked at that. On OS X, support OpenGL. We know that we could support Metal. That's what we know. We didn't implement it. And on Linux, we just support OpenGL, but we are fairly certain we could support Vulkan there as well. This is a demo running. This is OpenGL demos running on NEC, then on Windows. And yeah, go over. That's how long we will know that this is Windows. And here we are running on Linux. The same OpenGL code in JavaFX. Completely integrated into the scene graph. What do I mean with that? Fully integrated into the scene graph. Let me just bring up my demo. I'm running out of time, but give me a second to show you that this is real. Our desk code. So I can run that guy, hopefully. So we start the external rendering process. This is our triangle. Then we animate that. These are JavaFX animations. Fading in, fading out, resizing. We can overlay it with JavaFX content. We can even apply effects on it. Cool, right? So this is fully integrated in the JavaFX scene graph. It's just a node for JavaFX, and we can apply transformations, effects on this guy. And it works on Windows, Linux, and OS X. Isn't it cool? We also support multiprocess support. We can support external process rendering. So the renderer can run in its own process on the operating system. The demo I showed you with the factory. This was running in an external process and going cross-process. So when the rendering dies, your application is not dying, for example. This is very important to some applications. We only support that on OpenGL. On Windows and on Windows we have OpenGL and 3D. On OS X we have OpenGL. On Linux we cannot do cross-process. We probably could with Vulkan APIs, but we've not explored that yet. And I have a big announcement to make today. We are, and have an hour ago, open sourced the Drift API inside the FX Clipse project. The pull request is there. What's missing yet? We need to go to the contribution process at Eclipse. Caveat, we only support Java 8 at the moment, but we could do that in Java 11 without a problem. Well, by reaching to internals and by adding, really, we cannot, there's no public API for that. But generally speaking, the code is easily ported to Java 11 as well in future, and that's the future plan. For sure. But currently we are targeting JavaFX 8. Oh, and the final thing, if you want to work on not just boring business UIs together with me, we are hiring in Innsbruck. Innsbruck is a nice location to live. So if you need a job, apply for it, and we can do such amazing projects together. Thank you.